Tonight, somewhere, someone is going to take a first sip of alcohol and feel warm relief spread through their chest. They'll call it relaxing. They'll call it unwinding. But what's actually happening is one of the fastest chemical hijackings your brain will ever experience. Alcohol doesn't just make you feel different. It rewires in real time the exact systems that decide what you want, what you fear, and what you'll do to get more of it. So what is actually happening inside you when you drink? And why does a substance that damages nearly every organ it touches still feel like a reward? The answer starts within seconds of that first sip, before you even feel it. Alcohol is a small molecule, small enough to cross straight through your stomach, lining into your bloodstream before food even reaches your intestines. Within 5 minutes, it's already in your brain. Once there, it does two things at once. First, it boosts a chemical called GABA, your brain's main slowdown signal. GABA is why your muscles loosen, your words slur, and your anxiety fades. Second, alcohol blocks glutamate, your brain's main speed-up signal. Together, that's a system-wide dimmer switch, less excitement, less inhibition, less fear. For a few hours, your brain runs quieter than it normally does. But your brain hates being quiet for long. Neuroscientist Dr. George Koob, director of the National Institute on Alcohol Abuse and Alcoholism, has spent decades mapping what happens next. He describes addiction not as a single event, but as a cycle. And the cycle begins the moment the alcohol starts to leave your system. Because your brain doesn't just passively absorb that GABA boost, it fights back. It starts producing more glutamate to compensate, trying to restore balance. It's a survival reflex, not a punishment. Your neurons are simply trying to return to normal. The problem is timing. Alcohol leaves your bloodstream faster than your brain can undo the changes it made. So for a window of time, you're left with less GABA calming you down and more glutamate revving you up. That mismatch has a name most people know but few understand: anxiety. That racing heart at 4 a.m. isn't guilt, it's chemistry. It's glutamate, unopposed, firing through a brain that spent the night suppressed. But the chemical story doesn't stop there. It gets stranger. Once alcohol is inside your liver, an enzyme called alcohol dehydrogenase breaks it down into a compound called acetaldehyde. And acetaldehyde is roughly 30 times more toxic than alcohol itself. Normally, a second enzyme, ALDH2, clears acetaldehyde almost as fast as it forms. But nearly 40% of people of East Asian descent carry a genetic variant that slows this second enzyme down. For them, acetaldehyde lingers: flushing, rapid heartbeat, nausea. Researchers studying this variant have found something almost protective about it. People who carry it are statistically far less likely to develop alcohol use disorder because their body punishes them immediately for drinking too much. Which raises an uncomfortable question. For everyone else, whose body clears acetaldehyde efficiently, what's stopping them? The answer lives deeper in the brain, in a region most people have never heard of, the nucleus accumbens. This is your brain's reward center, and alcohol reaches it through dopamine. Not by producing joy directly, but by dismantling the brakes that normally keep dopamine in check. Dr. Nora Volkow, director of the National Institute on Drug Abuse, has spent her career using brain imaging to track this exact process. Her research found that with repeated use, the brain doesn't just release dopamine during drinking. It begins releasing dopamine in anticipation of drinking. The sight of a bar, the sound of a bottle opening, the smell of a particular room. All of it starts triggering the same neural spike that used to require the drink itself. This is called cue-conditioned dopamine release, and it's the same mechanism in different forms behind nearly every addiction ever studied. But here's the part that explains why addiction deepens instead of fading. Volkov's imaging studies found that with repeated heavy use, the brain's dopamine receptors don't stay the same. They shrink in number. Fewer receptors means the same drink produces a smaller and smaller effect. This is tolerance, not weakness. Biology. adjusting downward. And it creates a cruel loop. As receptors shrink, ordinary pleasures, food, laughter, connection start feeling flatter too, because they rely on that same blunted system. Alcohol becomes not the thing that makes life feel good, but the only thing that still can. Meanwhile, one more region is quietly losing ground, the prefrontal cortex. This is the part of your brain responsible for weighing consequences, delaying gratification, and telling you to stop. Alcohol suppresses it directly, which is why judgment fades before movement does. But over years of repeated exposure, imaging studies show this region can lose volume and connectivity. The very system you'd need to resist the next drink is the same system alcohol wears down first. So the cycle Koob described isn't just emotional, it's structural. Reward pathways demanding more. Stress pathways screaming louder during withdrawal. Judgment pathways growing quieter. 3 systems, each one bending further in the same direction with every cycle. And there's one more player almost nobody mentions. Alcohol suppresses vasopressin, the hormone that tells your kidneys to retain water. That's why you urinate more than you drink, and why your brain, an organ that's roughly 75% water, ends up mildly dehydrated by morning. That dehydration alone accounts for a meaningful share of hangover headache and fatigue. It isn't punishment for drinking, it's plumbing. None of this happens because someone is careless or undisciplined. It happens because the human brain evolved reward systems built for scarce, natural pleasures. Food after hunger, connection after isolation. Alcohol simply floods a system that was never calibrated to receive this much, this fast, this repeatedly. Which brings us back to that first sip, the warm relief spreading through the chest. It was never really relaxation. It was a 5-minute head start on a chemical negotiation your brain would spend the next 12 hours trying to settle. Tonight, somewhere, someone will take that sip again. And their brain, quietly, will already be planning the next one.